6 graphs of rational functions. Oh, and a little bit of domain also. All right, so find the domain of the function f. Use limits to describe the end behavior of f at the values of x not in its domain. So basically, we've got something like f of x is equal to -3 over x minus 1. And so initially, we're looking at the domain. So what would, or how would I go about finding the domain of a function like this? Yep. So x minus 1 equals 0, so x is equal to 1. So that means that the only thing that has a problem with this function is the 1, and so my domain would be from -infinity to 1, union 1 to infinity, and obviously not including because that's what causes the problem. And so basically what they're looking for here is they want us to evaluate what happens at that value. Okay, because rational functions, with the way that they graph, basically ends up, if you had a graph, it ends up being something like this and something like this is typically approximately what a rational function is going to look like, obviously at its base value. So I want to look at the limit as x approaches 1, and when we put this little negative sign in the kind of like the exponent of it, that means from the left. So in this particular situation, we would be looking at something like 0.999999 and so on and so forth. Okay, so something that's really, really close to 1, but on the left side of 1. Now, the other one that we'll do, I'll get to in a second, is going to be from the right, but of f of x. And so basically, if I put in 0.999999, okay, into that function up here, what's happening? So I'm going to end up with -3 over basically -0.0000000001. Okay, something like that. And so when I divide by a really small number, what happens? You get a really big number. So this is going to go to infinity. And because it's a negative over a negative, that's why it's positive infinity. Now, on the other side of 1, if we have the limit as x approaches 1 from the right of f of x, so the positive sign up here means from the right. So this would be something like 1.000001. You know, obviously I'm being a little obnoxious with what I'm saying, but that's what it means. It means something really close to it, but not quite touching it. So if I were to plug that in up here, that gives me that minus that is something like a positive 0.000001, you know, whatever the case is. So -3 divided by that would be what? So a number divided by a really small number is a really big number, and I have a negative over a positive, so this one is going to be negative infinity. So basically what this is telling me is if I were to graph it and look at it, okay, essentially I've got a vertical asymptote at 1, right, because that's where there's a domain problem. So I pretty much got an asymptote at 1. Now, there's also going to be a horizontal asymptote because it's bigger on bottom, so horizontal asymptote would be where?
0.
0. Okay, so I'm just going to extend this out. This is just more for reference for you. These problems aren't asking you to do this. I just want you to see it. So basically, at 1 from the left, it says that I go to positive infinity. So basically, because of the fact that this is negative, it's reflected. 1 from the right, so as I come from this direction, getting really close to 1, it goes to negative infinity. So this graph is basically was reflected because of that negative sign in front. So this is more so just for you to see what this visually looks like. As I approach 1 from the left, it goes to positive infinity. So it shoots up this way. Okay, we're talking about the y value as the infinity part. As I get to 1 from the right-hand side, I'm getting closer and closer and closer. And as I get closer, this shoots down to negative infinity. So as x gets close to 1, from the right, it shoots to negative infinity in the y. As it gets close to 1 from the left, it shoots up to positive infinity in the y. Okay, so that's what the end behavior part is talking about. So this is more just a visual for you. The only thing we actually needed was this part right here. The graph is just an FYI for you. Now, the 3 makes other things happen, but we don't care about that. I'm just trying to give you a rough sketch of what it would look like. All right, number 4, so same instructions as that one. We've got f of x is equal to 2 over x squared minus 1. Now, this one is going to look a little different because of that squared on the bottom. But initially, finding domain, how would I find the domain for this one? Yep, so x squared minus 1 equals 0. So x squared is equal to 1. So what does that mean about x then? X is equal to what? So plus or minus 1. So that means both of those numbers, positive and negative 1, are going to cause an issue. So everything except for negative and positive 1 will be included. So my domain for this one is going to look something more like negative infinity to negative 1, union, negative 1 to 1, union 1 to infinity. And so basically when I do this, I now have to do the limits 4 times because I have 2 values that I'm trying to check because it wants the end behavior at the x values not in the domain. So at 1 and negative 1. So I'm going to start out with the positive one just because it's usually a little easier to deal with. So the limit as x approaches 1 from the left of f of x. So again, from the left, I'm looking at something like 0.999, so on and so forth. So I have a positive 2 divided by basically 0.00001, that's negative, okay? What happens? And what sign's going to be on it? A positive divided by a negative. Negative. So this one is going to be negative infinity. Then at x approaches 1 from the right of f of x. So again, that's something like 1.00001. So I have 2 divided by basically 0.00001. So what is that? I have a positive divided by a positive. Yep, positive infinity. So then I also need to check at negative 1 because that's the other one that's a problem. So when I do this, the limit as x approaches negative 1 from the left. So now this is something like negative 1 from the left would be like negative 1.00001. I'm going to rewrite this down here too over x squared minus 1 so we can actually look at it. So if I plug in this, okay, this negative 0.001, I've got 2 divided by I've been forgetting to tell you to square it, but on that one it didn't matter because it was positive either way. But now I've got a negative value getting plugged in. Okay, negative squared is going to become, okay, minus 1.
It would be positive.
It's still going to be positive, so positive divided by positive is positive. So this one is going to be positive infinity. And then the limit as x approaches negative 1 from the right. So this is something like negative 0.99999, okay? So now I take that value and I square it. I get a positive minus 1.
Negative.
It's going to be negative. And then when all that's said and done, I've got a positive divided by a negative, really small number, so it's going to be negative infinity. So these were reversed in a sense from the right and the left, but it makes sense because when I did 0.999 or negative 0.999, I got a negative infinity in both cases, and then I got a positive in both cases on this. So obviously this is a little bit dramatic, but that is what's happening, which is going to lead into the next problems where it will actually help us. So in your notes, just to give you a reference for what we're getting ready to get to, you had this stuff about end behavior for the vertical asymptote is at x equals a, and we look at, basically, we just looked at end behavior in the sense of what happens at as x approaches a from the left and the right. We just pretty much did this part. But the next problems are going to also add on this. And so the end behavior for the horizontal asymptote is that as x approaches negative or positive infinity, wherever our horizontal asymptote is, that should happen as x approaches negative and positive infinity. Okay, so as x gets really, really big or really, really small, okay, we're looking at what is the y value going to, and that's going to be wherever our horizontal asymptote is. So it's kind of just a verification of our horizontal asymptote to say, hey, we did it right. So describe how the graph, wow, I can't talk of the given function can be obtained by transforming the graph of the reciprocal function. We're not really doing that because, whatever. But identify the horizontal and vertical asymptotes and use limits to describe the corresponding behavior. So basically what we just did in combination with also the horizontal asymptotes now. We did it as domain, but that also is obviously the same as vertical asymptote. So number 8, f of x is equal to 3x minus 2 over x minus 1. So I'm going to try to find my vertical and horizontal asymptotes first, and then I'll do the limits to go with them. So vertical asymptote would occur where?
X equals 1.
At x equals 1. And I'm going to leave room to do my limits below that. And then horizontal asymptote is where? Bobo, Bosco, Bodno.
Zero.
Both the same, right? X over x. Use the coefficient. So what would that be?
3.
Yep, 3. So y equals 3. So for the vertical asymptote, we basically do what we did up here. So at 1, I'm going to approach 1 from the left and the right and see where it's going. So the limit as x approaches 1 from the left of f of x is equal to, so 1 from the left would be 0.99999. Now, you have to pay attention because I now have an x on the top as well. So we always have to make sure we're careful about that. But I've got 3 times 0.99999. That's not really going to change drastically because that's still going to be around the 3 ballpark range. Minus 2. Okay, so I've got what? Okay, so it's still going to be positive. And then on the bottom, I've got basically negative 0.0001. So I've got a positive number divided by a really small negative number, and what is that going to produce? Yep, negative infinity. And then the limit as x approaches 1 from the right of f of x. So that's going to be a little bigger than 1, which means on top, I've basically still got a positive number on top, because that's basically 3 minus 2 is 1, okay? Divided by a positive, basically 0.0001, and so what is that going to produce? A positive infinity. So that's how we do the vertical one. The horizontal one, though, says that basically the limit as x approaches negative infinity should be equal to the limit as x approaches positive infinity. And if that's true, then that should be equal to 3, which is our horizontal asymptote. Okay? So the way to look at this to actually verify that, what you did is correct is if we plugged in, I'm going to do the positive infinity one. If we plugged in, let's say 500, okay? Now, as x gets really, really big, is a minus 2 and a minus 1 really changing anything? No. So I'm ignoring that. All I care about is my highest powered terms, which is all I ever look at for horizontal asymptotes anyways, because everything else is irrelevant. So if I have 3 times 500 divided by 500, okay, what essentially is happening?
It got smaller than like. what
Well,
was
3
supposed
times
to.
500 divided by 500 would be what?
3.
3. Okay, so that tells me that basically at infinity, okay, so I'm just picking 500 because it's a big number, it's 3. So if I put in negative 500, if I have 3 times negative 500 divided by negative 500, I get
I got lost when you were saying all that. That was a lot.
3 times negative 500 divided by negative 500. You get 3. So the answer is 3. And so we basically just verified that what we said our horizontal asymptote was is actually the case. So let's say that for some reason you thought this was a Bobo instead of a Bosco, and you said that it was supposed to be y equals 0. Well, when you plug in those numbers, hopefully you would have recognized that you did something wrong and have been able to fix it. So this is pretty much just a let me check and make sure that I'm doing it correctly kind of thing. So another one, 10, we've got f of x is equal to 4 minus 3x over x minus 5. Now, this one has a vertical asymptote where? At x equals 5. And I'll do the limits of that in a second. Now, what about a horizontal asymptote? At negative 3. Yep. So basically we get rid of the 4 and the 5, the negative 5 on the bottom. So I've got negative 3x over x. So you realized, fortunately, that this should be like this. Seeing if I was going to stump you or not. Okay, so that means my horizontal asymptote is at y is equal to negative 3. And so to go back and do the limits for the vertical asymptote, I've got the limit as x approaches 5 from the left. Okay, so that would be something like 4.999, so on and so forth. So I've got negative 3 times basically 5. Okay, not exactly, but that's 15 plus 4, that's a positive. Okay, divided by 4.999 minus 5, that's going to be a negative. So a positive divided by a negative is negative infinity. I guess I could write my little f of x there. And then, wait a minute, did I do that right?
I don't think so.
Nope, there's a sign wrong.
Oops.
This is negative. I was looking at that. It
Oh.
should be positive. That was my bad. It's supposed to be a negative. Because negative 3 times a positive number would be negative minus, or plus 4 would still be a negative divided by a negative, which is positive. I always look at this little negative sign and end up doing it wrong. That's why I have to go back and look at it again. I was like, wait a second, something's not right. And then the limit as x approaches 5 from the right would be 5.0001. So on top, I've got a negative times a positive, which is still going to be negative, plus 4, that's still going to leave me out as a negative. Then on the bottom, I've got basically 0.001 left, which is a positive. So where's this one going? Negative infinity. There we go.
For real this time.
Yeah, for real this time. And then for the horizontal, the limit as x approaches negative infinity should be equal to the limit as x approaches positive infinity. And so again, the plus 4 and the minus 5 are pretty much irrelevant. So if I plug in 500, I've got negative 3 times 500 divided by 500, we get
3.
negative 3. And if I did negative 500, I'd have negative 3 times negative 500 divided by negative 500, I get
Negative 3 still.
negative 3 still. So I'm good to go. All right. Where's this? Find the horizontal and vertical asymptotes. Use limits to describe the corresponding behavior. So basically the same thing. It's just under a different little title section. And this will be our last one for today. The last thing we'll look at tomorrow. It's just going to be basically I modify the instructions of what I want you to do. So 20 f of x is equal to 3x squared divided by x squared plus 1. So, vertical asymptote would be where?
X equals -1. No.
You should set it equal to 0 first.
Okay, so x squared plus 1 equals 0.
Because it looks like it's going to come out like imaginary.
So x squared equals -1. Are there any values I can possibly plug in for x that I square and give me -1?
No.
Nothing squared gives me negative, so that means I have no vertical asymptotes. There are none, which means I don't need limits to do anything because there aren't any. I only use limits when there actually are. Okay? So now, horizontal. Do I have a horizontal asymptote? And if so, where?
Y equals 3.
Y equals 3. I must really like threes today. So 3x squared over x squared, that gives me a 3. So then again with the limits, the limit as x approaches negative infinity should be equal to the limit as x approaches infinity. And in that case, if I plugged in 500, 3 times 500 squared divided by 500 squared, I would get
You answer. I have
3.
3 right.
3. Okay. And so that would give me 3, obviously, in both cases. And so that would be how we would do those. Basically, to give you a rundown of the one we're doing tomorrow, or we'll do 1 or 2 of them, but basically they give us a function that doesn't have like just a simple thing on the bottom. We'll have to do some factoring on the bottom. And it's possible sometimes something on the top and bottom cancel nicely, and then it simplifies it for us. Otherwise, we'll be finding basically where X and Y intercepts are, if there are any, and then also looking for horizontal and vertical asymptotes, again, if there are any, obviously. But we'll do one or two of those. They're not that hard. They're just kind of long, which is why I'm just going to wait, and then I'm assuming she'll be back tomorrow, because then that way she kind of gets a rundown of everything we just did, other than the limits. There aren't limits involved with those problems because they're pretty lengthy. But limits are always a way to do these problems. They're just not typically people's first pick, but it's good to know because when you get to calculus, we do a lot with limits. Limits become a really good friend of ours. Not necessarily as good of a friend as the unit circle, but it does become a pretty good friend of ours. So, it's good to know.